This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 4 of Fix It Yourself, where we're tackling something that makes a lot of people nervous: basic electrical work. Today we'll help you figure out what's actually going wrong when your lights start acting up or outlets stop working, so you can tell the difference between a simple fix and when it's time to call the pros. Let's get into it. Your light switch fails. 10 minutes later, it's working again, and nobody called an electrician. In many homes, the difference between broken and fixed is just knowing how to shut power off safely, identify 3 wires, and swap one simple device without guessing. A dead outlet or flickering fixture often isn't a mystery problem at all. It's a loose connection, a tired device, or a tripped protection feature quietly doing its job. Modern homes layer safety into the wiring like a good novel. Breakers, GFCIs, and sometimes AFCIs, each watching for different plot twists in the current. When one of them reacts, the symptom you see is simple: no power where there used to be. The skill you're building in this episode is learning to read those symptoms before you ever pick up a screwdriver. You'll trace the clues from panel to device, learn when a GFCI upstream is the real culprit, and see how line versus load, grounding, and secure terminations turn from intimidating jargon into a checklist you can calmly work through. Some electrical problems aren't problems at all. They're the system doing exactly what it was designed to do under stress. A space heater and hair dryer on the same circuit, a wobbly plug that's been bumped one too many times, or a backstabbed connection slowly loosening behind drywall can all create the same symptom: silence and darkness. In this episode, you're not just hunting for what failed, but for why this spot failed now. You'll learn to read patterns across multiple rooms, notice which devices share a home run to the panel, and spot subtle clues: warm plates, discolored screws, buzzing, before they become hidden burn marks. Most mystery electrical issues shrink fast once you zoom out from the single dead spot and look at the whole circuit as a system. Start with a simple map. Which outlets and lights die together when a breaker is off? That cluster is your working zone. Jot it down or snap photos as you flip breakers. This becomes your personal circuit atlas, way more useful than faded handwriting in the panel. Within that zone, patterns matter. If the failure is at the physical end of the run, a far bedroom outlet, the last light in a hall, the real fault is often just upstream, the last working device before the dead one. That's where a loose terminal, tired device, or damaged pigtail is most likely hiding. The dead outlet itself might be perfectly fine, it's just not getting fed. Temperature and sound are early warning signs. A cover plate that feels warmer than the room without a heavy load plugged in, faint crackling when you gently wiggle a plug, or a subtle buzzing that changes when a load switches on all point to stressed connections or overloaded boxes. You're not fixing based on vibes, though. You're using these as clues to where you should open the box after you've verified power is off at the breaker. Once the cover comes off, think like a careful inspector, not a hacker. Look for mixed metals: copper tied to aluminum without a listed connector, wire nuts without enough twisted engagement, insulation nicked by overzealous stripping, or multiple conductors stuffed under a single screw that's only listed for one. Grounding deserves equal attention. All grounds in the box should be bonded together and firmly tied to the device or yoke, not left floating. Modern add-ons complicate and protect at the same time. Combination AFCI/GFCI breakers or receptacles can protect entire downstream runs, but only if terminations are neat and torque is correct. Smart switches and outlets introduce low-voltage electronics that are picky about neutral quality and box space. Crowding them into shallow boxes invites heat and nuisance failures. Treat the manufacturer's diagram as law, not suggestion. When in doubt, odd wire colors, unexpected splices, visible heat damage, the safest repair is to stop, document, and bring a licensed pro into the loop with clear photos and notes. A simple way to think about basic electrical repairs is to treat each device like one player on a team. You're not trying to beat the system, Just keep every player in the right position and in good shape. Take a bedroom where half the outlets work and half don't. Instead of guessing, you'd test from the last working receptacle outward, looking for the exact spot where power stops passing the ball downstream. Often the fix is just remaking a tired splice, shortening a scorched wire end, or moving a conductor from a springy backstab to a solid side terminal. Or consider replacing a standard receptacle with a GFCI or smart outlet. The wiring may be identical, yet the device's body is bulkier and needs careful folding of conductors so nothing is pinched. In tight, older boxes, that might mean adding pigtails to reduce the number of conductors on each screw and choosing compact, listed connectors. The repair isn't just electrical, it's also about physical layout so everything fits without strain. Future-proofing basic repairs means thinking a step beyond make it work today. As more devices self-monitor, you'll read fault codes on an app instead of chasing a dead outlet with a tester. Your troubleshooting notes become data. Which rooms overheat? Which circuits see constant motor loads? Treat each small fix like sketching a map in a growing atlas. Over time, you'll see where to add capacity, upgrade wiring, or separate sensitive electronics from heavy-draw tools. Your challenge this week: pick one small electrical annoyance, a buzzing dimmer, a mystery wall switch, a lamp that randomly blinks, and investigate it without opening a box. Log when it happens, what else is on, and which breaker controls it. Like field notes on a hiking trail, those observations turn vague problems into clear, fixable paths. This was OwlUp, your daily step forward. This series continues with more chapters on OwlUp.co. Visit OwlUp.co to access the complete course and continue your learning journey. See you there!